Hey guys, so today we're going to start looking at some switch features. Basically, a switch is a networking device that allows the connection of multiple nodes into a network. And so we're going to look at the different functionalities that are available within a switch. We'll look at the different physical ports as well as the logical capabilities that a switch has. So let's go ahead and look at the desktop. Okay, here we are at Module 7, Section 3, Switch Features, Port Configurations. A network switch is a smart device, and that's what makes it different from a hub or, back in the days, a hub just flooded the entire network with packets. It didn't have any control over what went where. It didn't have any processing going on inside it. Nowadays, switches use ARP tables to kind of route traffic, and so there's a lot of things going on configuring a switch. It's a smart network device that functions as a multi-port network bridge by receiving and forwarding data packets from the source to the destination device using packet switching technology. It sends data packets to designated destination ports using MAC addresses. This is your ARP table. Your ARP table acts as kind of a database between MAC addresses and port numbers. So the switch port is classified as the access port or the hole in the switch that you plug the network cable into, if you want to get down to it. Physical switch port can connect various devices, and each device's needs vary. Each switch port is individually configurable as an interface to meet a connected device's need. You can modify speed, whether it's duplex, half duplex, whatever. Flow control you can set. Port security you can set. Port aggregation, you can aggregate ports, or port mirroring, and we'll talk about that a little bit later. Don't forget, stay up with these participation activities because they count towards your grade. Port mirroring is known as switch port analyzing or span. Roving analysis port, span and wrap are two types of port mirroring. It's a network switch function used to send a copy of network packets transmitted from one switch port to another switch port for packet monitoring. So if you want to send, you have ports that you are suspicious of, maybe you can span those ports so that not only does it send the packets to the destination, but it also sends a copy of those packets to, let's say, a computer in a different office that's running Wireshark. And so you're capturing those packets so you can keep an eye on what's going on that other port. Port mirroring can be used to mirror inbound, outbound, or both types of traffic. Port mirroring is implemented in LANs and WLANs and VLANs to identify, monitor, and troubleshoot network issues. The destination port is connected to the monitoring or security applications, like Wireshark, that analyze or debugs the data packets. Port mirroring is commonly used in network appliances that require monitoring. For example, network intrusion, network prevention systems, things like that. All right, participation activities. Then port security secures a network by preventing unknown devices from forwarding packets. Security is increased by limiting access to a switch port within a list of MAC addresses. So basically, you're specifying what MAC addresses can be attached to a specific port. A switch port's MAC address list can be configured statically or dynamically. So dynamically is kind of like DHCP with IP addresses. You can say anything that connects to this port can be added to the ARP table, and now the switch will send it packets. Or you can configure the ARP table statically and say only these approved MAC addresses can forward packets. Only packets matching an allowed port MAC address, which would be in the ARP table, a secured packet, that those packets are allowed through the port. If a packet does not match the MAC address, if the correct MAC address is not there, then the packet is considered unsecured and it is dropped. It limits the number of addresses for a given switch port. It secures the network from unknown devices, and it can be implemented on a per port basis. So if you've got some ports that are specific to guest network, then that may be what you want to do there. Once again, participation activities, then you can tag a port. That is a tagged port is also called a trunk port, and it's configured to carry traffic from multiple VLANs. The most common encapsulation method is 802.1Q. That's .1Q. The encapsulation inserts an 802.1Q tag into the frame. That creates a tagged frame. That tag is 4 bytes, 32 bits in size. An untagged port is an access port. That's a switch port configured to carry traffic from a single VLAN. To support legacy devices that don't use VLAN tags, native VLANs are used. A native VLAN is an unused VLAN used to receive all untagged frames, because there are older switches still in service, and some of those don't even work. They didn't even have virtual LANs when those switches were built. So participation activities, and at that point, then we are done with section 7.3, and you can continue on to section 7.4. Okay, so if you have any questions, please let me know. I can be reached through the Canvas inbox or ask me in class, and I'll do my best to help. Have a good day.